Hello dear students, today we are going to learn how to find integral factor of the given linear differential equation of first order. If the linear differential equation is given in the standard form, so what is the meaning of standard form? So standard form means the differential equation can be written in this form: dy by dx plus p times y is equal to q, where p is function of x and q is also function of x. If you observe this differential equation carefully, then you can easily find out that in the first term there is derivative of y with respect to x, and see the coefficient of this dy by dx, it is 1. So in the standard linear differential equation, the coefficient of dy by dx must be 1. After that, plus sign must be there, and in the second term you must have seen y and its coefficient is a function. It may be constant or it may be a function of x, but remember that this p is not again a function of y and is equal to q, and here also q is not a function of y. It must be a function of x or constant term. So this type of form is called as a linear differential equation, and we can find its integral factor by using the formula e to the power integration of that p with respect to x. The abbreviated name of integral factor is if. But the naturally question arises, what is the integral factor and how and what is its work? So let me explain. Integral factor is such a expression or quantity when it multiplied to the left hand side of the given differential equation, then that left hand side after multiplication will become an exact derivative or perfect derivative of some function. For example, suppose e to the power this integration p dx, this is the integrating factor, multiplied to the left hand side of this equation, then after simplification we will get these two terms, and you know that these two terms are nothing but derivative of this product. So this is the first function, this is the second function, and these two functions are expressed in terms of multiplication. We are finding it's a derivative. So to get the derivative of this product, we have to use product rule. So keeping first function as it is, derivative of second function, that is dy by dx, plus keeping second function as it is, derivative of the first function, and the derivative of this exponential function is this one. So this is the beauty of this integral factor, and that's why it is called as an integral factor, because when it multiplied to the left hand side of the given differential equation, that left hand side will become exact or perfect derivative of some expression. But keep in mind, according to this formula, if you want to find integral factor, then you must know the methods of integration, because in this power integration is present. So let us consider one example. Find integral factor of the differential equation dy by dx plus y upon x is equal to x cube. So this is a standard linear differential equation, and to find the integral factor we need the value of p, and the value of p is nothing but the coefficient of y, and that is 1 by x. So here the value of p is 1 by x, hence according to formula integral factor is equal to e to the power integration p dx, but the value of p is 1 by x, and we know that in the integration, when the derivative of the denominator is present in the numerator, then the integral is log of denominator. And also we know that when the log and it's a base e, here nothing means the base of log is e. This log with base e cancel out with this base e, and we are getting x, and therefore the integral factor of this differential equation is x. But this is just a routine method, regular method. Now we will see some another methods to get integral factor in quicker way. So when this type of question will be asked, integral factor of the differential equation dy by dx plus 2 by x into y is equal to x is, and the four options are given to you. The first option is x square, another option is x cube, third option is x, and fourth option is x raised to 4. So how we can find integral factor? By using our regular method. So here in this equation the value of p is 2 by x, and therefore use the formula of integral factor, and after integration we will get integral factor as x square. But there is another method, and that is a short method. How to use that short method? So to use the short method, first thing is make sure that the coefficient of dy by dx in the given differential equation must be 1. So here it is 1, therefore we can use this short method. And how to implement this short method? So to get the integral factor, follow the given steps. What are the steps? The thing is that you have to check this equality for every option. What is this equality? Derivative of option is equal to coefficient of y divided by coefficient of dy by dx, and the whole quotient multiplied by the same option. So if I am considering option A, that is x square, then the derivative of x square I am putting in the left hand side, then coefficient of y, that is 2 by x, divided by coefficient of dy by dx, that is 1, and again multiply by the value which is present in the option A, that is x square. and we have to check whether these two sides are equal or not. If they are equal, then first option is our answer, that is integral factor. So the derivative of x square is 2x, and if you simplify the right hand side, you will get again 2x. Therefore both sides are equal, and hence the option A satisfy this equality, and therefore option A is the right answer. Now we will see another short method for another example. So in this example, we have to find integrating factor of differential equation 1 plus x square into dy by dx plus 2xy is equal to tan x. So this is a linear differential equation, but not in the standard form, but still we can find its integral factor very quickly. But to use this method, we need its 4 options. Remember, these methods we can use only in MCQ questions, multiple choice questions. So the first option is tan x, second option is 2x, third option is 1 plus x square, and fourth option is x square. So how to decide which option will be the correct answer? So I'm stating another short method and how this method works. So for this method, step number 1, write the whole left hand side of the given differential equation, but the only change is just change the middle sign. Here in this equation, the middle sign of left hand side is plus, so therefore you change that sign and you write whole left hand side as it is, that is 1 plus x square into dy by dx. The second term is 2xy, original middle term is plus, and now I am changing that into minus. Now equate these two terms equal to 0. So equate these two terms with 0. Now step number 2 is check which option will satisfy the above equality. So one by one I am checking this equality. So for option A, in the option A, tan x is given, and I want to check whether this tan x is integrating factor of the given differential equation or not. So for that, I'm putting this tan x instead of y in this equality. So 1 plus x square keeping as it is, y is here, I am putting tan x, therefore derivative of tan x is sec square x minus 2x keeping as it is, and instead of y I am putting tan x. And if you see, these two terms will not cancel out with each other, and therefore the answer of these two terms will not equal to 0, and hence we can say that option A is not our integral factor. Now we will check the same thing for second option. So for option B, here in option B 2x is given, so I am putting y is equal to 2x in this expression, and I will check whether this 2x will satisfy this equation or not. So 1 plus x square as it is, the derivative of 2x is 2 minus 2x keeping as it is, and the value of y I am considering 2x. So if you simplify this, the answer will not equal to 0. and therefore option B is also not correct answer. Now we'll go for option C. So in this option, I am putting y is equal to 1 plus x square here. So what will happen? 1 plus x square keeping as it is, the derivative of 1 plus x square is 2x minus 2x as it is, and the y we are keeping 1 plus x square as it is. And look at these two terms, both terms are equal with opposite sign, therefore they will cancel out each other and we are getting 0. That means that the option C will satisfy, or option C is satisfying this equation. Therefore option C is the required integral factor of the given linear differential equation. So it's so simple. Now we will see another question, and you can use these methods for any linear differential equation to find out its integral factor. The question is, integral factor of tan x into dy by dx minus sec square x into y is equal to x is, and the options are tan x, cot x, sin x and sec x. Now how I can check which option will be the correct answer? So as per the previous method, I am writing the left hand side as it is, just changing its middle sign. So construct this tan x into dy by dx. Instead of minus I am taking plus. Second term is sec square x into y and equate with 0. Now I am putting option 1 by 1 instead of y here, and I am checking that whether the option A will satisfy this equation or not. So our first option is tan x. So therefore I am putting tan x instead of y in this equation. So what will happen? So for option A, tan x into the derivative of first option is a sec square x plus sec square x, and y is nothing but our first option, that is tan x. But unfortunately the sum of these two terms will not become 0. Therefore option A does not satisfy this equality. Therefore option A is not integral factor of this differential equation. Now let us see what happened when we are considering option B. So for option B, that means cot x. So tan x keeping as it is, the derivative of y means derivative of cot x is minus cosec square x plus sec square x as it is, and y is nothing but cot x. So whether it will be 0 or not. So for that purpose I have to simplify this trigonometrical expression. So instead of tan x, I am putting sin x upon cos x, multiply by cosec square x means 1 upon sin square x with minus sign, plus sec square x means 1 upon cos square x, and multiply by cos x upon sin x. You can cancel out sin x in the first term, sin x get cancelled, cos x get cancelled, and you will be getting minus 1 upon cos x into sin x plus 1 upon cos x into sin x. And see, both terms are equal with opposite signs, therefore it is equal to 0. It means that cot x satisfying this equality, and therefore option B is the integral factor of given differential equation. To download PDF notes of this video, please click the link given in the description. Bye bye.